He has partnered with some of the leading names in the industry, including GE and EOS. He is here to clear some of the misconceptions of 3D printing. Over to you, sir.
Thank you. Thank you, Sampathji, and all the members present over here for having me over here and giving me an opportunity to clear some of the misconceptions with 3D printing and some of the technologies that we use in 3D printing. So, I'll just start off with Ad Solitech. So, the vision of Ad Solitech is to develop ecosystems around additive manufacturing. So, what do we mean by ecosystems? Like, first is to offer cutting-edge solutions, and then to ensure that the aim center it is self-sufficient and it flourishes on its own. And we have some of the partners that we are partnered with: Syntratech, EOS, Sunser, and Moxidans. So we've covered all this over here. So if somebody could help me read out the names over here, and then we could discuss about each name in detail. So anybody would want to read out whatever is written over here. So when we talk about manufacturing, okay, generally there are two kinds of manufacturing. One is subtractive manufacturing and additive manufacturing. So subtractive manufacturing is generally removing material from a piece of object or a block, and additive is adding material. So yeah, examples of subtractive is CNC and VNC, and additive is 3D. Can anybody help me understand this? Like now we always say 3D printing. Is 3D printing a prototyping technology or a manufacturing technology?
It's a prototyping technology.
And why do you say that?
So because we had studied in the last section in material science.
Okay. Alright.
So rapid prototyping technology.
So does anybody differ from this?
So
Anand says 3D printing is more of a prototyping technology.
Sir, actually it was developed as a rapid prototyping technology, but nowadays it can be used for manufacturing also. As as the technology has grown, we have seen that it is used for like construction purposes also.
Okay. So yeah, like it is also termed as additive manufacturing for the same reason, because it can also be used for manufacturing. And does anybody know why the name 3D printing? Why is this technology called as 3D printing? As you rightly mentioned, it was developed as a prototyping technology. Like, so the name 3D printing, right? It is presumed that it was given to the field by Mr. Obama. So when Obama was visiting his advanced technology lab, so he came across this fascinating technology, and then he asked, like, what does this technology do? And then when people explained him, then he said, this is similar to 3D printing. And then the media caught on this technology saying that, yeah, this is 3D printing. And he always believed in this, and he said, this is a technology for the future. And that is when the media picked up and the hype around 3D printing came up. Else, rapid prototyping has been present from 1980s. So this is not something new. This is something which is already 30 years, 40 years old. So yeah, coming back to is this prototyping or is this manufacturing? So we do have some opinions on prototyping, some opinion on manufacturing. But when we see manufacturing is defined as creation of goods with the help of equipment, labor, tools, or chemical processing. The benefits of 3D printing, yeah, like they're enormous. Like it all depends upon. So how many of them are from the core, and how many are from the computer background, like the IT background? You could raise your hands. So if anybody is. Excellent. And how many of them intend to remain in core, and how many of them would want to switch to IT? Anybody switching to IT can raise their hands.
Nobody is interested now. They have seen the situation. Now they have realized and they have gone.
So yeah, we have had I think this is the third day, so 3 good sessions on 3D printing. So this basically can help retain talent in the core fields than switching on to the IT sector. You have freedom of design. Uh, you could tinker now. What was happening is with subtractive, a complex part was being split into circles and squares, which could be manufactured easily and then assembled to form the complete part. Now with 3D printing, we are going in the opposite direction. We don't want small squares and circles. We would want to build a part completely as on its own. So now the number of parts come down. Like there have been case studies wherein say 5 million parts have come down to say 12 parts or 3 parts. So this way we can join small parts and manufacture as a single part. So yeah, the history of 3D printing, like it began in 1980, 86 is when the first 3D printing SLA was patented. Can anybody take a wild guess as to when was the first 3D printer or the first metal printer that was installed in India? So we have a estimate as late 2000s. Yeah, the first metal printer that was installed in India was in early 2000s, like 2001. It was at CMTI in Bangalore, and that printer is still being used actively. So it was like a road story where every part was manufactured independently and then assembled. So some of the material technology, as you would have come across, is FDM, SLA, SLS, and DMLS. So let us understand it. Like, would anybody be keen to answer this as to what's the difference between FDM, SLA, and SLS? Any one difference between all these three? Like, how do you point out, or how do you know, like, if 3D printing is the right technology? Then in 3D printing, what technology might be applicable to you? How would you decide on that?
Based on the type of input, powder, liquid.
Yes. So you're right. FDM, SLA, SLS has different forms of input material. So I'll just show you a videos of about all this three, and then we compare between all the three technologies as to which technology can help us build what. Because an SLA printer cannot replace SLS printer, and SLS cannot replace FDM, and FDM cannot replace DMLS. So every technology has its own advantages, own disadvantages. So, in a nutshell, like this is what the end product would look like. When we see FDM, there will be a lot of layer marks. When we see an SLA, it would be a very smooth finish kind of a part. And when we see SLS, it would be a lot of grainy structures around. Because SLS is done using powder, so you would have that feel of the powder grainy surface. SLA is using resins, though the surface would be like injection molding, it would be very smooth. And FDM would have layer markings on it. And then we go on to the SLA. With SLA, this happens in a lot of vat of material. So there's a liquid vat of material in which parts are built using laser. So the parts basically are cured, which is a photopolymer resin. And we'll also see a video, but this is how the parts come out once it is built. So in FDM, there's a head that extrudes material. In SLA, the parts are basically cured or built from top down. So, uh, so these are the kind of printers that basically use to develop parts in SLA, and these could go up to as that is 1600, like 1.6 meters also. So these printers are also used in manufacturing. So I'll just run a video as to how the parts are basically built using SLA. So this is how the laser strikes a vat of resins, and this is how the reporter moves. And once the parts are built, this is how the part comes out of the printer. So this is manufactured using the SLA technology. So these are parts that are being built using SLA. So one could actually beat architecture, beat, so you will have come across robotics like the panels of the robots. These are built using SLA, which is again like injection molding. So yeah, like all these other parts have been built using SLA technology. So in this, basically, when you see the top right hand corner, like this is a device that has been built using 3D printer and a combination of vacuum casting. So it is, you all could start off building parts, manufacturing parts using 3D printers also. Then we come across to SLS. So as was rightly mentioned, SLS is using powders. So again, yeah, I'll run a video so that you all could understand how the parts are using SLS technology as well. Yeah. So this is also using laser. The laser centers the part. So this is how the laser basically strikes the bed of powder, and the parts basically centers together. The powder centers. So this is a CAD file. This is as the laser strikes, some kind of fumes that come out. So a CAD file, as we rightly mentioned, the height is varied to number of layers, and each layer is printed. This is how the laser would print each layer in next slide. And another layer of powder comes in. and these powders can be reused. So we also have a sample of SLS. So this is how an SLS powder. You would feel this, the surface is very direct. So these were also used to center sand. It is because when we talk about SLS, the build platforms, the inside environment is not controlled. In DFMS, the inside environment is controlled. So it helps in building parts, in stable parts.
Both cases, both are, means the part is building in vacuum atmosphere, right?
No.
AMLS and SLS.
In SLS, it's not building package. So one is the difference in laser, second is the environment the parts are being built on.
There's a close-up mechanism in SLS and ALMS, both are same. Here also melting and sintering. There are also melting and sintering, right?
And that is why different printers are manufactured, because people have not been able to use the same printer for multiple applications. Probably going forward, so when you talk about industrial grade metal printers, like each part being built could go up to maybe 400, 500 kgs also. Each part at all maybe. So this is an example of a band printer where you have a 6-axis robo controlling the end effector, and this will help you on build parts which can go up to say 2 meters, 3 meters. The largest part was built using MAD is close to about 10 meters. So a 10-meter bracket was built using MAD. This is an end effector or end tool of 6 axis. So each layer is material deposited and also cured at the same. So when you talk about materials, some of the common materials that are used using MAP is titanium, inconel, and grains of aluminum and steel. So before we move on further, would anybody want to know anything about the technologies in detail, like any query on technologies? we have gone through plastics, metals, and metals we have gone through DMLS and VAM.
Could you brief us about how 3D printing used for creating drugs in pharma industry?
Drugs and pharma industry. Again, as I mentioned, like the 3D printers itself do not know what they are being used for. It's
Correct.
like a software platform where the language itself, there are endless possibilities. And it depends upon the requirement that people can build on applying this technology to various industries. Okay, so when we start off with a 3D printer, we'll have to have a CAD file. So these CAD files can be obtained in two ways. Either a designer develops a CAD file, or second is through reverse engineering. So by reverse engineering, one can scan an object, get the CAD file of that, modify a bit, and then manufacture it. So the starting source is always a CAD file, but the source of the CAD file can vary. It can be through an imagination of a person, or it can be through extraction from a scanner. So once we have that CAD file, then the process becomes pretty simple to manufacture that part using a printer. So generally, a CAD workflow would have a CAD software. Sometimes it is also simulated as to see how the part should come out. Topology optimization, this is gaining a lot of interest. Basically, people get inspired by nature. So even there's a lot of scope of IT sector in 3D printing as well.
So what is this licensing software and machine software?
So we'll come to that in the next slides. So what happens is when you make a CAD file, the printer does not understand what is a CAD file. So this CAD file has to be broken down into numbers which the printer can understand. So this work is taken care by the data preparation software. So it basically helps you to give support to that part and helps you slice. Like we saw, a part was sliced into a number of layers, 100 layers, 500 layers, or 1000 layers. So this slicing is done by the data preparation. This software is breaking the conventional rules. So the beauty about this is the same software is scalable to different technologies. Generally for SLA, there's a different set of softwares that people use. For SLS, different modules, and for DMS, different modules. But with Voxendance, it is now possible to scale the same software to various technologies. Basically, add structures, less, and then give the front of. So some of the features that are available in Voxendance. So all this depends upon how well you design a file, because printer could do its job. So the way you design a file would affect the end result of the part that is being manufactured. There are a lot of tools that come in for design, and this is what is given out during training. Like we are going to in-depth training sessions that we usually should out when we are installing the machines there. So depending upon the technology that one goes in for, that design goals that come into play. And all this helps you make use of your 3D printer. Overhand features, like these are support features that go on. Sometimes you get parts when you print through FDM, a lot of you see filaments of wires that keep protruding out of the part. All these are issues of the support that is being given. Yes. So earlier what had happened is people did not have control on manufacturing. Now one could control every bit, every segment of the part that is being manufactured using 3D printing. Because as you saw, printing or manufacturing is having as dots. Every layer is being printed. So you could have control of every layer, every height, 100 microns of the part that is being manufactured. So when this kind of control is possible, why don't we make use of that control? And that is when comes this topology optimization. Now when you manufacture a part conventionally, okay, through CNC machining or casting on these, the parts come out as solid parts. Okay, here's a case study wherein this part, when we were going to commissioning case studies, the weight of this part was close to about 5 kgs. And we optimized this part because we were able to control the air gaps between the parts. So when we redesigned this part using topology optimization software, the weight came down from 5 kgs to 1.9 kgs. So a lot of material saving happened without compromising on the part. And second, if you consider this part as a heat exchanger, you see the surface, the functional surface area where the air comes in contact, it drastically increases from 100 centimeter cube to 10,023 centimeter cube. Yes, this is not. So I could share more details about this. I'll shut it up. So similarly, this is an example of a manifold. Again, the weight of this drastically came out from its original design of 25 kgs to 16 kgs. And using the stainless steel part, if it was steel aluminum alloy part was 12.3 kgs.
Are these prototype or they are being the working model? These are prototype or
So this can be used as a functional part as well. Now when we talk about this thing, all this comes from the change in mindset of people. So
we have a lot of number is more then every manufacturer may not be very cost effective. I think so the feeling
Money
for prototyping
money first.
and it is with
right. So there are 2 points to this. One is when we talk about comparison of additive manufacturing and conventional technologies, people talk about one component through CNC and the same component through 3D printing. You're right. Like 3D printing does not stand a chance because that component was designed for subtractive or milling process. But when you compare an entire assembly, and this, since we are on this discussion, so this design versus this design. So this part was made through subtractive process, and on your right was the same functionality of the same part is made through 3D printing. So when you talk about, say, a part of this, okay, this segment, when you compare the cost of this segment and 3D printing versus the subtractive technologies, 3D printing does not stand a chance. When you compare the cost of the entire assembly versus manufacturing that part using 3D printing, 3D printing stands a chance. Right? It's a lot more cost efficient than manufacturing it conventionally also.
which means that you have a old system, a small system requires replacement. So creating a whole system again versus redesigning or making in a 3D printed metal or other kind of materials will be a better.
Yes. So in fact, this was the same suggestion that also came out from Adani Defense, like I was at a meeting with them. And that is when they suggested it is better to go with products that are being built in the concept stage at the moment, where 3D printing could be a part of the manufacturing process. So yeah, I'm sure like if there are any queries, please do let us know and we would be happy to address that or learn from it. That's it from my side.